we are going to learn the first chapter, function, which is coming under the unit problem solving techniques. The subtitles under this chapter are subroutines, functions, function specifications or definition, parameter and arguments, types of parameter. As this chapter is related with problem solving techniques, I just want to recap some of the titles. What is computer algorithm? An algorithm is a step-by-step sequence of statements to solve a problem. Okay, fine. Then what is a computer problem? For example, find the factorial of a given number, find the sum of three numbers. These are all very simple computer problems. Sometimes the computer problem will be very big. Even though if it is a small problem or a big problem, the programmer has to write the algorithm. Algorithm can be written to solve the problem. Sometimes while writing an algorithm, some steps are done repeatedly. Then that repeating steps are separated as a small section of code called as subroutines. So, have an idea? What is a subroutine? Repeated steps are separated as a small section of code while writing an algorithm is called as subroutines. Then the interesting factor along with the function is, in programming language, these subroutines are called functions. So subroutines and functions are more or less same. Now we have learned what is a function. Then we have learned when the function should be used. When the function is used, when there is a necessity to write a repeated steps, then we have to use the function method. Now, how to use a function? Here comes the idea. What is a function specification or a definition? Let us consider an example, a colon equal to 24. Definitions bind values to names. In this case, the value 24 being bound to the name A. See the another example. Let max of A be result. If A is greater than B, then A, else it is B. So let is a keyword, max is a function name, and the process is written as a line. This is the format to define a function. Now, you have to learn the term parameter and argument. Parameters are the variables in a function definition. Arguments are the values which are passed to a function definition. Regarding the parameter, there are two kinds. One is parameter with type, parameter without type. What is that? See the example. Parameter without type is nothing but the data type is not mentioned. See the example. Let is a keyword, min is the function name, three variables are there, x, y, z. They are going to find the minimum among the three variables, then the coding is given. See the same thing, but there is an instruction of x colon int within the parenthesis, y colon int within the parenthesis. Here data type have mentioned and it must be within parenthesis. This is the difference between without data type with data type. It's very easy, no? Now see the another concept, that is recursive function. See, let rec, there is a keyword, power AB, B equal to 0, then 1, else A into power of B minus 1. I know you can understand. Then the power A to the power of B means if it is 2 to the power 8 means the 2 is repeated 8 times and they will find the value. So the keyword let followed by the name of the function and its arguments. Then the formula that computes the image of the argument is written after equal symbol. If you want to define a recursive function, use the keyword let rec instead of let. The function definition which call itself is called recursive function. I hope you have. In this session, we are going to see the chapter function part 2, which is under the unit problem solving techniques. I hope you have all viewed the first video, function part 1. Let's start. In this session, we are going to see the important topics: interface and implementation, pure function and impure function, side effects of impure function, chameleons of Chromeland problem using function, an interesting problem. Let's start. What is the interface and what is the implementation? Interface just defines what an object can do, but won't actually do it. What is the meaning? What is an object? An object is a thing which is having a characteristics and a behavior that is defined as the object. For example, a pen is object, a table is object. If a pen is object, a pen is having a characteristics like it's white in color with red cap. You can describe anything else like that. Then what is the behavior? It is used to write. So this is said to be an object. Okay, then I think these things you have known while you are learning your C++. Anyhow, now we will have a recap. Take the object gear. We know that it is used to increase the speed, but we don't know how the gear increase the speed. I know gear is object. It is used to increase the speed. If I move the gear, automatically the speed will increase. I know this, but I don't know how it is increased the speed of the engine. That means the mechanism I don't know. Up to this level, it is interface. Then come to implementation. Implementation carries out the instructions defined in the interface. That is, the execution part of the interface is said to be implementation. So, interface is the template or the function prototype. Implementation is the function definition which actually execute the process of interface. Is it clear? See this. Min 568. By seeing this, I can understand that it is a function with 3 values and it is going to calculate the minimum among the 3 values. I know this. I can understand this, but I really don't know the logic how this function minimum is going to do the process. This is interface, the real explanation or the definition which actually executes the thing. That is implementation. Simply, function prototype is said to be interface. Function definition is said to be implementation in this level. Is it clear, children? Now, come to the next topic. Pure function. What is pure function? It might return the same result for same argument values and it has no side effects like modifying an argument. See example, it's a Python program and the output. 5th chapter onwards we are going to start the coding, but just have a look. Print len of welcome. That is, I want to print the length of the word welcome. First time execution the result is 7. Next time execution the result is 7. Obviously it should be 7 only because the word is welcome alone. So the number of letters will be 7 always. This type of function is said to be pure function. That is, it will give the same result for same arguments. Then come to impure function. It always return different result for same arguments. What is the meaning? See an example. Print random.ran integer within the bracket 1, 10. Don't be in a panic. What is this? I don't know. We'll see in later chapters. Just have a look. There is a function called rand integer. That means I want to print a random number between the integer 1 to 10. So while executing this, I am getting the answer as 5. Next time the answer is 2. That is, this function print randomly any number between the value 1 and 10. So this is the reality because I want it random number. So each time the function will give different values. It will be useful in many times. So the impure function characteristics is it will give different result for the same argument values. It is very useful in many places. So pure function is same result for same arguments. This is also necessary. impure function is different result for same arguments. This is also in need. So we must decide where I have to use pure function and where I have to use impure function. Next, see another step in impure function, that is side effects. One of the most popular groups of side effects is modifying the variable outside of function. I hope you have learned the scope of the variables. That means the variable inside a function, outside the function, local variable, global variable. We will see this in detail. It is also in Python. Now have a look. This is y is above the function, so it is in global place. The function here is inc, that is increment, and inside the function there is a change y equal to y plus x. That means the 0 value is changed, and this function is returning the value of y. So this function is used to change the value of a variable outside the function. In some place it is very important to change a value. So the impure function is useful in many places. See a Python program, y equal to 0, print y. So the value of y while we print will be 0. Here there is a function definition. Def is a keyword to define a function in Python. The function name is given, open bracket, close bracket, colon. Don't panic, don't think we don't know what is this. Everything will be explained in detail in later chapters. It is given here just for an example. Y equal to 8 plus 5. So the value of y is changed here, and we are asked to print here the value of y. Increment, open bracket, close bracket. This is said to be the function call. Here the function is called. So the control will go here, the definitions will be executed. And this, we are going to see the chameleons of Chromeland problem using function. Construct an algorithm that arranges meetings between two different types of chameleons so that they change their color to the third type. In the end, all should display the same color. What's that? First step, there are many number of chameleons of 3 colors. Actually, we don't know the number. That means we don't know how many numbers are in yellow, how many numbers are in blue, how many are in pink. But there is a strategy, that is meeting between two types of chameleons will change their color to the third type. That means if a blue and yellow chameleon meets, then both will change to the color of third one, that is pink. If it keeps on moving like that, third step, that means at the end, the end should be all the chameleons in the same color. So how to achieve this? To achieve this, there is a input condition, that is A equal to B. Be the input property. What is the meaning? Here A, B, C, that are the counting of first, second, third chameleons. If it's so, then the first and second or any two must be in same number. Then the output relation, that means at the end, A equal to B equal to 0. That means all the chameleons in first and second place will be 0. Then the third counting automatically be the summation of all the 3 numbers. This is the end result. So let us represent the number of chameleons of each type by the variable a, b, c and their initial values a, b, c. See the function name with 3 variables, and the input is a equal to small a equal to capital A. That is first chameleon, second chameleon, third chameleon. The input property is a and b must be in same number, and the expected output is at the end a and b which are in same size must become to 0, and the third type must be the summation of all the 3. The condition is if a and b decreases 1, then c has to increase by 2. Let's see interestingly what's the mechanism behind this. As it is in while loop, it is said to be iteration. So first yellow color in 3 number, then B, blue color also in 3 number. This is the input property we require. Any two must be in same number. And the third one can be any number. It may be same, may not be same. Here I am taken as 4. So yellow color 3 chameleons, blue color 3 chameleons, and the pink one 4. In the first iteration, A minus 1, that is 2. B minus 1, that is 2. Then C plus 2. That means this yellow and the blue meets, so it changes to pink. So one number decreased in yellow, one number decreased in blue, two number increased in pink. In the next iteration, this 2 will decrease to 1, A minus 1, B minus 1, C plus 2. So it is 8. Can you see this? Here one yellow and blue and changes to pink. Then the third iteration, this yellow and blue will meet and join with the color of pink. So A minus 1, 0, B minus 1, 0, C plus 2, and it is 10. So the final thing is the C is equal to the summation of A plus B plus C, that is 3 plus 3 plus 4. 10 is here, and you can see the changes in the chameleons. All the 10 are here but with the same color. Is it interesting? Thank you. We are going to learn chapter 2, Data Abstraction. The main concept you are going to learn in this session is data abstraction, abstract data type, constructor and selector. So before entering to data abstraction, first we'll understand what is abstraction. The process of providing only the essentials and hiding the details is known as abstraction. I'll repeat. The process of providing only the essentials and hiding the details is known as abstraction. For example, when you want to drive a car, you don't need to know how the engine was built or what kind of material the tires are made of. You just have to know how to turn the wheel and press the gas pedal. Let's see again. Abstraction is: a car owner need not be a mechanic. That means a person who drives the car need not be a mechanic, but he must know some basic techniques to drive the car, like steering, gear changing, etc. So at first point, abstraction is providing only the essentials and hiding the details. Okay, that is abstraction. What is data abstraction? Data abstraction is the invention of new data types. It separates functionalities from representation. Programmers need not worry about how code is implemented. They have to just know what it does. We don't need to know how data is represented internally. We just need to know how to interact with it. It's really a good mechanism or concept which is in great use today. Because of the introduction of object-oriented programs, data abstraction is in live. All the softwares which want to be up to date must follow OOPS concept, and one of the best concept is abstraction, and data abstraction is simple. The programmers need not to worry about how code is implemented. They have to just know what it does. By seeing this, it shows that the programmer's work is less. Let's see what's happened. Abstract data type. Abstraction, data abstraction. Next is abstract data type. Data abstraction is supported by defining an abstract data type. Simply it is ADT, which is a collection of constructors and selectors. That means data abstraction concept is implemented by defining a data type that is said to be abstract data type, and it is a collection of constructors and selectors. Then what is the constructors? Constructors create an object bundling together different pieces of information. You can compare this with your constructor in C++. While selectors extract individual pieces of information from the object. Constructors create an object. Selectors retrieve information from the object. See the example now. Constructors. Constructors are functions that build the abstract data type. Selectors. Selectors are functions that retrieve information from the data type. Which data type? Abstract data type. Now, imagine there is a city abstract data type and it is having information of name, latitude, longitude. That is name of the city, latitude of the city, longitude of a city. City equal to make city of name, latitude, longitude. To create an object for city ADT, constructor function is used. Here the make city is a constructor and it is defined to create the object. Then what about the selectors? To extract the information of a city object, you should use functions like get name, get latitude, get longitude of city. Make city is also a function. Get name is also a function. But make city creates an object for the abstract data type. So it is coming under the concept of constructor. Get name is retrieving the information from the object city. So it is coming under the category of selectors. Let's see another example. Consider a ADT, that means abstract data type of college. It is having admission, department, staff. For example, I have given college equal to make college, admission, department, staff. To create an object for college ADT, constructor function is used. What is the constructor here? Make college. To extract the information of a college object, you should use functions like get departments, get staff. Do you understand what is constructor, what is selectors? Recall again. Abstraction, providing only the essentials and hiding the details. Data abstraction, the programmer need not worry about the implementation. He must know how to use it. The third, the abstraction. Data abstraction is defined by having a abstract data type by combining a constructor and selector functions. Data Abstraction, Chapter 2. Important contents you are going to learn in this session are rational numbers, list, tubules. Data abstraction. You know very well that to define an abstract data type, we need the collections of constructors and selectors. Data abstraction means providing only the essential things and hiding the detailed procedures. That is said to be data abstraction. That data abstraction concept is supported by abstract data type. To define an abstract data type, we need constructors and selectors. Constructors create an object. Selectors extract individual pieces of information from the object. Both the constructors and the selectors are functions. Up to this level, you have learned in your previous video. I hope you remember that. Okay. For creating an abstract data type in our program, that should contain two parts. What are they are? The part that operates on abstract data and the part that defines a concrete representation. So we are going to see what is this concrete representation and what is the link between this and the abstract data type. See the Example of representation of abstract data type for rational numbers. So before defining the abstract data type, we must know what is a rational number. Rational number is nothing but it's a fractional number. So you know, for example, take the number 8 by 3 or 19 by 23. All these kind of numbers are fractional numbers. It will have a numerator and a denominator. In this example, 8 is the numerator and 3 is the denominator, and this is the result of the fraction. Am I right? This is a mathematical thing. Now we are going to implement this concept in our abstract data type concept. As you know, to define an abstract data type, we need constructor and selector. Constructor is a function. Selector is also a function. Here, constructor name is rational and it is having two parameters, n and d. Selector are numer of x, denom of y. Now you have the operations on rational numbers defined in terms of the selector functions numer and denom and the constructor function rational. I hope you understand this. But you have not yet defined these functions. What is the meaning of this line is, I didn't define the numer and denom, but I am saying that this numer of x function is going to return the numerator of the rational number x, and denom of y is going to return the denominator of the rational number y, because we are constructing based on the imagination. Is it clear, children? What you need is some way to glue together the numerator and the denominator into a compound value. That means we are framing the concept with the constructor and the selector. We are saying that rational is a constructor function and it is going to have two parameters, and numer of x and denom of y are selector functions, and it is going to return the numerator of rational number. We are saying these things, but we didn't define the exact implementation of these two selectors. So this, up to this level, it is said to be abstract data type. And this methodology of program designing is said to be visual thinking. We have not yet said how a rational number is represented or how the constructor and the selector should be implemented. This kind of program designing is said to be visual thinking, because visual code is a code that calls functions that do not yet exist. That means up to this it is not defined, but for the completion it should be defined later. Is it clear, children? Now, have some idea about the abstract data type and the concrete data type. So, abstract data type independent of its implementation. You know this point. We have discussed only this point yet. Next point is, they are just ideas called black boxes with a defined behavior. So they are all the ideas. To implement them, you have to choose a suitable concrete data type. Is it clear? So come to the concrete data type. Implementations of a relatively simple concept. First point. They are the implementations of a relatively simple concept. Then they are basic data structures typically provided by the computer language. So they are the basic data structures. In concrete data representation, a definition for each function is known. So to build the abstract data type, I should know the concrete data type, that are the basic structures provided by the computer language. If I am using C++ means I should know about C++. As our syllabus is for Python, here we are going to discuss what is in Python regarding the concrete data types. Why we are learning the concrete data type means based on this only we are going to build our abstract data type. Enable us to implement the concrete level of our data abstraction, Python provides a compound structure called pair, which is made up of list or tuple. Both the list and the tuple are a data type coming under the category of pair, which is a concrete level of data in Python. Now we are going to see in detail about list and the tuple data structure. Actually, it is a very interesting concept. Do you remember the word array in C++? Can you see a sweet box? With this box is containing only one kind of sweet, because I want to represent the array as collection of similar data types. Then what about list? On seeing this, can you guess the difference? Same sweet, different types of sweets. So collection of different data types. Then what about this? It's also collection of different data types, but they are all packed. So I want to implement a concept here. List and tuples both are same. Collection of different type of data, that is simply said to be collection of different data types. List changeable, tuples unchangeable. Array collection of similar data type. Do you remember the array in your C++? If not, I'll recall it. So list. List is constructed by placing expressions within square brackets. Can you see the example? My list. It's a user defined variable. You can use any variable here. Equal. Within the square bracket, I have to say all the data in that list. 10, 30, 1. There is another example. Here there is a word, that is string, collection of characters, and a float number because it is 3.14. Then an integer number because it is not having any decimal points, 10. Again there is a list here, 2, 4, 6 within a square bracket. So these are the possibilities what I can do with the list. That means list can store multiple values. More than one value can be stored in list. And what type of value can a list store? A list can store any type of value. That means it can be a combination of integer, float, string. Even another list can be a member of this list. Is it clear? Is it interesting? Am I right? Because you know array, collection of similar data type. But you are going to learn a list. I can hold any type of data in one name. Is it interesting, right? Just like our array, the list also fetched in the same pattern. How our array is fetched in C++ through the index value. Do you remember? Same thing. List 10, 20. The 10 is the data value, 20 is the data value. 10 data value is fetched through the index value of 0 because the index values always starts with 0. And the 20 data value is fetched through the index value 1. Look here. Here list 10, 20, but there is another assignment x, y equal to list. That means the first variable x holds the first value of 10. Second variable y holds the second value of the list 20. That means x equal to 20, y equal to 20. This also possible. This methodology also possible in list. Below given the mathematical representation of list. That means a list is a combination of an index value and a data value. So 0 index value, data value is 10. 1 index value, data value is 20. This concept is said to be pairing. Because of this facility, list is coming under the concept of pair. It is also a book back question. Come to tuples. Tuples are similar to list. Then what is the difference? Two difference. One in syntax is there in the list I have to use square bracket, here parenthesis. Second difference is list can be changed. That means I can change the element in the list, but in the tubules I cannot change. That is the difference. Apart from that, all are equal. Here nums 1, 2, that means nums of index value 0 is having the data value 1. Nums of index value 1 is having the data value of 2. Is it clear, children? You are going to learn list, tubules, string in elaborate in coming chapters. So we know very well that list is a collection of different data types. But imagine a situation handling complex data like a person's detail. That means I need a person first name, last name, his ID, email address, sometimes for contact number, I can have anything like that. So in that time of situation, if I want to handle the data using list means I have to create a list name. Here the list name is person. As I can say it is a list because of the square bracket. If it is in parenthesis, then it will be a tubule. Here it is a list. So first data Badmashri, it's a first name and the last name data and the ID and the email address I have given. I can represent a detail in a list like this, but there is a practical problem here. Representation does not explicitly specify what each part represents. Meaning is, I cannot tell the user that the first index value 0 is the first name, second index value 1 is the last name. By giving such kind of instruction is not easy and it is not advisable also. So how to overcome this problem? Here comes the solution. For this problem, instead of using a list, you can use the structure construct to represent multi-part objects where each part is named. That means, instead of giving the index number as 0, 1, 2, 3, I can label a name here. How it is possible? Only through class. Do you remember your class objects in C++? Same concept. They are defining a class name, and they are creating a function name with the name creation and the data members. Same structure what you learnt in the C++. Person, class name. The member function is creation and the data members or the variables are field name, last name, ID, email. The person is referred to as a class, while P1 is referred to as an object. You know that to access the content in a class, we must create an object. Is it clear, children? Data abstraction, abstract data type, concrete data type, abstract data type, and the usage, then the list, tubules, their difference, then the need of class construct in the abstract data type concept. Therefore, we can define a class as bundled data and function that works on that data. For all the above example and explanation, one can conclude the beauty of data abstraction is that we can treat complex data in a very simple way. That means creating a class concept to handle the complex data is the main point of abstract data type in Python. Is it clear, children? Thank you for watching.